Hi guys, today's video will be about rows iteration in a pandas data frame. It's a very basic topic, but unfortunately in the internet there are a lot of advices that are not always good in terms of performance, and they don't cover some of real-life cases. So to start, let's load an IMDb dataset as an example. Here is the dataset. Let's review the original file also. So as you may see, there are several columns here, and specifics of this dataset is that there are encoded symbols known as key encoded symbols in the text, and later we will need to handle this. Let's view a couple more things about the dataset. So as you may see, the actors list is a column that looks like column of arrays, but actually it's read as a string, and we will need to parse it later. And duration column is an integer column. So speaking about the iteration, the first and frequently recommended way of iterating over rows, which is not the optimal one and has several disadvantages, is usage of iterrows. It looks like the following. So what we do here is we iterate over the data frame over each row, and if there is a duration that is larger than our current max duration, we reassign the max duration, and then we use eval command to transform such a string into an array of strings. Here is an example of what can be extracted. And then we add the actors to the set. And finally, we print the max duration and the sum of the actors that we have extracted. This is not the most efficient way to do this operation, but we will use it to demonstrate the disadvantages of this iterrows approach. Let's now use a bigger data set, like 100 times bigger, and do the same thing. I will copy paste this code and just modify it a bit. The video was sped up to just make the operation faster for you to review. But you may see that when we increased the size of the data frame by a factor of 100, the duration of the calculation also increased by a factor of 100, which is pretty bad. The dataset currently is not very big. It's about 100,000 of records, but it takes 11 seconds to do the processing. One more disadvantage of the iterrows is that it creates a series each time you get a row in the loop, and also it makes an interesting type conversion. Let me demonstrate it. So here I use loop that is interrupted after first execution, and you see that the row that is returned by the iterrows is a series, and which is also important that in this case the duration has class int. It's not actually a basic int but a boxed int, and it takes Python some time to make this boxing. This is needed because how the series works. So every value is converted to some general type for the series to have the d-type object. And it looks pretty okay in this case, But let's imagine that we iterate over a sub data frame with just a subset of columns. Interestingly, the D type now is not object, but rather float 64, and the type of the duration was int, class int, but now it's class numpy float 64, and the duration value has also like float view. This is because the star rating has a float 64 type in the original data frame, and the boxing that series creation requires results in such a conversion. This may be okay, this conversion may be okay in many cases, but sometimes it may result in unexpected behavior. For example, if you use the duration value in some context that expects the integer value, you will get an error. For example, in this case, so we'll use the latest value of the row, the one that was used here. And you see that we have an error here because this operation, like multiplying the list by some value, requires an integer value here. One more important thing to keep in mind when you use an iterrows is that you cannot modify the value of the row when you iterate over the data frame. So here we try to change the content rating for this column, but it is not changed and we have got no warning. So the operation just wasn't saved. There is a good way to make such a modification, and we'll show it later. And finally, speaking about the iterrows, I want to tell about the case that may justify the usage of the iterrows. It may look like the following. So this is an example of the code that may justify the usage of the iterrows in case each row requires a pretty long processing, some request to the database or reading from the disk or something else that is long by itself, and the overhead because of the series creation is not that big in comparison to the operation in the cycle body. And if the type conversion doesn't bother you in this specific case, the iterrows may be okay. It's pretty easy to read and it's very familiar to the developers who have used other development languages in the past. So now let's speak about the vectorization, the approach that is much better than the iterrows in almost any case. So I'll show several examples of what you can do with the help of vectorization. So here is a vectorized version of the same code that we had previously. Let's measure the execution time also. And you see that it executes pretty fast. And this long sequence of calls here allows us to parse this string into an array of string. So here we take a slice, like removing the first and the last symbol. Then we split the string using comma space, this. Then we explode the values to make the column contain a flat array, like this will be the first row, this will be the second one, and etc., etc. Then we remove this prefix and this last symbol also. And then we use strd code to handle these symbols. And finally, we get the same result. You see it here as previously. The difference at this small data set is not that big. So here we have about 10 milliseconds. And in iterrows, we had like 130 milliseconds. Both of them are pretty fast. But let's try to repeat the operation with a bigger data set. You see that the vectorized version takes about 800 milliseconds, which is more than 10 times faster than non-vectorized version. Usually, vectorized implementations are hundreds and thousands times faster than non-vectorized one. In this particular case, we have such a long duration for the vectorized implementation because of this part here. Let's try to do only the max part here. So we'll drop the string part and see only the number one. So we have about just 1 millisecond for this operation. Let's try to create an even bigger data set and see what it will take for the vectorized implementation to do the operation. So now the very big IMDb dataset contains almost 10 millions of records. And let's repeat the max duration calculation for this very big dataset. So the dataset is 100 times bigger, but the operation takes about 15 times more, which is really cool. It means that if you increase the size of the dataset, vectorized implementation will still perform really good. But keep in mind that not all the vectorized implementations are super fast. This string sequence of vectorized calls is an example of not very fast, but still quite a fast usage of the vectorized code. So there are many different operations that support vectorization in pandas. We will not speak about all of them here. I'll hopefully create a separate video about vectorization, but I will make just a couple more demonstrations. So we can calculate mean, and it also is pretty fast. And you see that sum is also pretty fast. Let's measure it. Yes. And also, there are several operations that probably are not that obviously are vectorized, but they're still pretty fast. And you are better to use them if it's what you need. So I'll show you what it is. For example, if you want to convert a data frame to a string, you can use a toString method. This one is also pretty fast, and it's much faster than iterating over each row and converting it to a string and printing it somewhere, blah, blah, blah. Also, if you want to convert it to the CSV, you hopefully know it already, but still I'll show it. You can use a toCSV method, which is also really fast. If you want to select a couple of random rows from the dataset, you can do, and it also will work pretty fast. Speaking about the modification of the data frame using a vectorized code, here is an example of what you can do. Let's say you want to have a custom rating that is different from the star rating. Let's start from just copying it. And now let's say you want to add 1 point to the custom rating if the duration of the field is equal or greater than 160 minutes. And you see that it works pretty fast. The rating is changed, so we have here the row with the original rating 9.2, we have the duration greater than 160, and the custom rating was changed. So there are really many different ways of how you can use this syntax, but you have to keep in mind that the vectorized implementation is much faster than iterrows. Also, if the vectorization unit isn't supported by pandas directly, but is supported by NumPy, you can easily convert pandas columns to NumPy array and apply vectorization afterwards. So here is a piece of the code that will demonstrate the conversion. So this values property converts the data to an NumPy array, and now you can apply any operation you want to this data as a NumPy array. Okay, so here we spoke about the vectorized implementation, but what if the operation you want cannot be vectorized or is really hard to be vectorized? What can you do? The first and in major part of the cases, the fastest alternative to the vectorization is the usage of list comprehensions. So we have iterated over almost 100,000 of rows and created a film record object for each, and it took us just 200 of milliseconds. The duration may be like different from run to run. Sometimes it's smaller, sometimes it's bigger, but it's about 150 or 200. It's pretty fast, and this kind of operation is an example of the case that cannot be vectorized. Like I have to create an object for each row. The second pretty good option, but a bit slower than iterrows, is the usage of Itertuples. So let me demonstrate it. So you see that Itertuples is also pretty fast. It may take a bit more time in some cases or a bit less time, but still it's pretty fast. You also may notice that I've accessed the columns in a different order, like they go like duration and title here, but title and duration here. While in case of list comprehensions, I have to be really careful to keep the order of the values here and here. This option is also quite good, and we'll speak about it a bit later. But let's continue our case and see what other options do and how fast are they. The next one is two records. So two records is a couple times slower than itertuples, and it basically uses NumPy feature of the record array. You can read about it more here. A cool thing about the records is that you can access the record either using .property syntax or as a dictionary. But in terms of performance, it's a couple times slower than the previous options. The next option that is slower than the previous ones is an apply. So you see that apply takes a couple more times longer than the to record and even longer than the previous options. The advantage of the apply is that you can use star star syntax to unwrap the values here and not list them like this, but just use a bit shorter syntax. The reason apply is that slow is because it also creates series each time. Let me show it. So you see that each row has a type of series, and pandas have to create this series, make the boxing, and etc. etc. One more thing you have to note about the apply, that it has quite a non-obvious axis equal 1, and axis equal 1 means columns in pandas. But in this case, axis equal 1 means iterating over rows. Just to show you the difference of the apply and the previous options, let's measure how much time it will take for the iterrows to do the same thing. So you see it's a couple times slower than apply and much slower than list comprehensions, about like 70 times slower. And one more option which is really not good, but still sometimes you may see it used, is using of .log. .log by itself is a great feature, but it is designed to access several rows at a time and not for iterating over rows one row at a time. You see that such an approach is even slower than iterrows. What we basically did is that we iterated over the index, selected each row using log syntax, and then created the film record. So it's very slow. Just to sum up the non-vectorized portion of the video, list comprehensions is the fastest one, and you have to probably use it if it works for you. But there may be some cases where Itertuples is also good. Let me show you one example. So let's say in your business logic you have some method that is used by you and probably by some other team members to do some operation. In this case, it's a synthetic validation. And there may be a lot of calls in here, like different checks, and you want to have a single object as an input and access its fields using easy to read syntax. So in this case, Itertuples may be good for you. You may notice that validate film record function can actually be vectorized, but it will require us to make the function dependent on the data frame. And in some real-life cases, you may want to sacrifice the performance, but be able to call the same function, for example, for the records extracted from the database, but not only for the data frame rows. An interesting note about Itertuples is what it does with types and what is the tuple itself. Let's look at it. As you remember, the iterrows did that strange type conversion. But what does Itertuples do? So what you may see is that the type of the tuple is pandas core frame pandas. Actors list is obviously str. Duration is class int, and its value is integer value. And you see that you can also access the values using integer indices, not only the properties. And also the value with the index 0 is the index itself, this one. So it's here. And let's check what happens with the itertuples if we take just star rating and duration columns. As you see, in this case, we still have int for duration and its value is preserved, which is cool. The next option you can use for iteration, which is pretty advanced, is a Python routine. You can read about it more in the internet. The idea is that you write a C code that makes the operation you want in an optimized fashion, and then you get the improvement in the performance. One more thing I want to speak about, which is not actually related to the iterating over rows, but also has an iteration in the name, is iteritems. So as you may see, this iteritems call actually iterates over columns. In the first item, we've got the star rating column, and first elements are like this, and we also see them here. So though it has an iteritems name and it may look like it is for iteration over rows, but it's not. So I wanted just to tell you about it for you not to be confused when you will see this method. And finally, for those of you who have watched the video till the end, here is the bonus. I want to show you the comparison of the performance of the different methods and tell a bit about the parallelization of the apply. So I will not execute the code. Again, if you will want to reproduce it, you can just open this notebook. The link will be below in the description of the video, and you can just reproduce it if you want. So first we will install the perfplot library, then the Swifter library, and import them. The basic idea of this benchmark was taken from this cool snippet of code, thanks to call this P33D for this one. So I've added a couple modifications to it. First of all, I've added a Swifter apply option here. It looks pretty similar to the normal apply, but uses the parallelization to execute the code. And here are some more tweaks, but generally the idea is the same. And we have the result. As you may see, the vectorization option is the fastest one, but Swifter apply at about 1 million records is pretty of the same speed. And in this case, the operation is pretty simple. It's A plus B, so just summing of two columns. The next option is list comprehension, then itertuples, then apply, and then iterrows. The picture is pretty similar to what we saw previously. Here we see that in Google Colab we have 2 CPUs and 1 core. And the second benchmark is made for the string split, explode, and parsing that we had previously, decoding using Unicode escape. So it's about the converting these strings to an array of actor names. And the same methods for the calculation. And what we see here is that for this complex operation, vectorization is almost of the same speed as itertuples or list comprehension. Apply is a bit slower, and Swifter apply is even slower, and iterrows is even slower. There are several interesting things here. To speak about them, let's switch to a more convenient view. So here is the result of the benchmark again. And we see that for a simple operation, the calculation duration remains almost the same for a vectorized option until we get about 100 of thousands of rows. And then it starts to grow. And at about 1 million records, vectorization takes about the same time as swifter apply. Though other options, since 100 items, grow linearly. But if you speak about a complex operation, the duration of execution for different options grow in about the same fashion, and vectorization also grows linearly. And what is also interesting is that for a laptop of 4 cores, the picture is almost the same, and for a powerful server with 60 cores, the picture is almost the same. I expected swifter apply to be faster on a complex operation, especially on a multi-core server, but I found out that swifter apply is pretty slow when DataFrame contains strings, and you can read about it more in the internet. So if the case we have will be a bit different, not related to strings, but some other heavy operation, then hopefully swifter apply will be faster than vectorization. In my practice, I saw such examples. But for pure arithmetic operations or similar simple operations, vectorization is the fastest option. You see it here. So guys, algorithm you can use for choosing the proper way to iterate is the following. If the operation you want to do can be vectorized, use vectorization. If operation cannot be vectorized, try to use least comprehensions. If least comprehensions doesn't work for you, for example, if you want to have a single object representing the entire row, use itertuples. If least comprehensions or itertuples are too slow, try swifter apply. And if it's still too slow, try Thyssen routine. And if you have any questions or comments, please write them in the comments to this video. Subscribe to my channel for not to miss new interesting videos about pandas, machine learning, and data science. And keep learning. Bye-bye.